here from Edureka, and I welcome you all to this live session on big data in AWS. So before moving further, let us have a quick look at the agenda for today's session. First, we will know what exactly is big data and what exactly is AWS. Then we will figure out why big data in AWS. Moving on, we will discuss how AWS can solve the big data challenges. And then finally, we will conclude with a demo. I hope I'm clear with the agenda, guys. Just a reminder, in case you have not yet subscribed to our YouTube channel, please do subscribe and also hit the bell icon so that you never miss an update from Edureka. And also, if you're someone who's looking for a course in AWS, then you can find the link for that course in the chat box. So before moving further, give me a quick confirmation whether you have understood the agenda and we are good to proceed further. Okay, so I can see a lot of positive response from the viewers online. So let us begin with our first topic. What is big data? You can consider big data as high volume, high velocity, and or high variety information assets that demand cost-effective, innovative forms of information processing, and this enables enhanced insight, decision making, and process automation. So big data comprises of 5 important V's which define the characteristics of big data. So let us discuss these one by one before moving to AWS. So as you can see on the screen, these are the 5 V's of big data. The first one is the volume, which corresponds to the amount of data that is generated every day. So many of us must be aware that social media generates a lot of data. E-commerce websites also generate huge amount of data. So these are the some sources that generate huge amount of data. And next is the variety of data. So it's not that data comes only in one format. So data can be structured, unstructured, or semi-structured. And the next V is the value. If you're not able to derive any value out of your data, then there is no use of such data. And the next V here is the velocity. So velocity here refers to the speed of data generation. And the final V in this big data is the veracity. So veracity is nothing but the inconsistencies and uncertainties in the data. So these are the 5 V's that are associated with big data. Now let us talk about what exactly is AWS. AWS comprises of many different cloud computing products and services. The highly profitable Amazon division provides servers, storage, networking, remote computing, email, mobile development, along with security. Furthermore, AWS consists of 2 main products, the EC2, Amazon's virtual machine service, and S3, a storage system by Amazon. It is so large and present in the computing world that it is now at least 10 times the size of the nearest competitor and hosts popular websites like Netflix and Instagram. AWS is split into 12 global regions worldwide, each of which has multiple availability zones in which its servers are located. These serviced regions are split in order to allow users to set geographical limits on their services, but also to provide security by diversifying the physical locations in which the data is held. So this was an overview of what exactly is AWS. And now let us talk about why big data in AWS. Scientists, developers, and other technology enthusiasts from many different domains are taking advantage of AWS to perform big data analytics and meet critical challenges of the increasing V's of digital transformation. AWS offers you a portfolio of cloud computing services to help manage big data by significantly reducing costs, scaling to meet demand, and increasing the speed of innovation. Furthermore, it helps you build, secure, and deploy your big data applications. Also, with AWS, you don't need hardware to procure and infrastructure to maintain and scale. Due to this, you can focus your resources on uncovering new insights. Since new features are added constantly, you'll always be able to leverage the latest technologies without requiring to make long-term investment commitments. So these were the reasons why AWS and big data are perfect companions. Now let us talk about how AWS can solve the big data challenges. So AWS has numerous solutions for all the development and deployment purposes. Also, in the field of data science and big data, AWS has come up with recent developments in different aspects of big data handling. Before jumping to tools, let us understand different aspects of big data for which AWS can provide solutions. So as you can see on the screen, these are the various services that are provided by AWS for big data analytics. The first one is the data ingestion. So data ingestion is nothing but collecting the raw data, which can be transactions, logs, mobile devices, and more. And this is the first challenge many organizations face when dealing with big data. A good big data platform makes this step easier, allowing developers to ingest a wide variety of data from structured to unstructured at any speed, from real time to batch. And the second service provided by AWS is the data storage. Any big data platform needs a secure, scalable, and durable repository to store data prior to even after processing the tasks. Depending on your specific requirements, you may also need temporary stores for data in transit. And the third service here is the data pre-processing. This is the step where data transformation happens from its raw state into a consumable format. And this is usually done by means of sorting, aggregating, joining, and even performing more advanced functions and algorithms. The resulting data sets undergo storage for further processing or made available for consumption via business intelligence and data visualization tools. And the fourth service is the data visualization. Big data is all about getting high value, actionable insights from your data assets. Ideally, data is available to stakeholders through self-service business intelligence and agile data visualization tools that allow for fast and easy exploration of data sets. So these were the services that are provided by AWS to handle big data. So now let us take a look at the various solutions provided by AWS for handling different stages involved in handling big data. So the first step is the data ingestion. So for that, AWS provides two tools, namely AWS Kinesis and AWS Snowball. So if you talk about AWS Kinesis, it is a fully managed service for delivering real-time streaming data directly to Amazon S3. Kinesis Firehose automatically scales to match the volume and throughput of streaming data and requires no ongoing administration. You can configure Kinesis Firehose to transform streaming data before you store it in Amazon S3. So for those who don't know what Amazon S3 is, we'll be covering Amazon S3 in the later part of this session. And the next tool for data ingestion is the AWS Snowball. You can use AWS Snowball to securely and efficiently migrate bulk data from on-premises storage platforms and Hadoop clusters to S3 buckets. After you create a job in the AWS Management Console, you automatically get a Snowball appliance. After a Snowball arrives, connect it to your local network, install the Snowball client on your on-premises data source, and then use the Snowball client to select and transfer the file directories to the Snowball device. So these were the tools for data ingestion purposes. And now let us talk about the data pre-processing tools. So as you can see on the screen, the tools used for data pre-processing are the AWS EMR and AWS Redshift. So now let us talk about the AWS EMR. For big data processing using the Spark and Hadoop, AWS EMR provides a managed service that makes it easy, fast, and cost-effective to process vast amounts of data. Furthermore, EMR supports 19 different open source projects, including Hadoop, Spark, and it also comes with managed EMR notebooks for data engineering, data science development, and collaboration. And now let us talk about the AWS Redshift. For data warehousing, Amazon Redshift provides the ability to run complex analytical queries against petabytes of structured data. So you can just imagine the amount of data or the volume of data that can be processed by Redshift. Also, it includes Redshift Spectrum that runs SQL queries directly against the exabytes of structured or unstructured data in S3 without the need for unnecessary data movement. So these were the tools for data pre-processing. I hope guys you're understanding whatever we are discussing here. At any point, if you have any doubts, you can post them in the chat box and my team is here to solve all your queries. So now let us move further and talk about the data storage tools provided by Amazon Web Services. So as you can see on the screen, there are two tools here, AWS S3 and AWS Glue. So AWS S3 is a secure, highly scalable, durable object storage with millisecond latency for data access. S3 can store any type of data from anywhere, be it websites, mobile apps, corporate applications, and data from IoT sensors or devices. It can also store and retrieve any amount of data with unmatched availability and built from ground up to deliver 99.99% of durability. And the second tool here is the AWS Glue. So Glue is a fully managed service that provides a data catalog to make data in the data lake discoverable. Additionally, it has the ability to do extract, transform, and load or the ETL to prepare data for analysis. Also, the inbuilt data catalog is like a persistent metadata store for all data assets, and this makes all of the data searchable and queryable in a single view. Moving further, let us talk about the data visualization tool provided by AWS. So as you can see on the screen, for visualization purpose, the tool provided by AWS is the AWS QuickSight. So for dashboards and visualizations, AWS QuickSight provides you fast cloud-powered business analytics services. It makes it easy to build stunning visualization and rich dashboards. Additionally, you can access them from any browser or mobile devices. So these were the tools that can help you solve any big data challenge for your project. And now we have come to the final part of this session, which is nothing but the demo. So in this demo, we will use sample data of endangered plant and animal species from the states of Australia. Here we will create an EMR cluster and configure it to run multi-step Apache Hive jobs. The EMR cluster will have Apache Hive installed in it. This cluster will use EMR-FS or the EMR file system as the original file system so that its data input and output locations are mapped to an S3 bucket. The cluster will also use the same S3 bucket for storing the log files. So this was an overview of the demo part that we're going to cover now. Okay, so before proceeding, guys, let me tell you, you need to have a free tier account of AWS for executing this demo. Okay, so first what we will do is, I'll just quickly show you the data set that we have. I'm going to share you the link for this data in the chat box. You can download this data from that link. So basically, these are the two CSV files. And as discussed, we are going to run Apache Hive queries on the top of this data. Okay, so these are the queries. So for that, I've created a text file and we'll just be uploading these text files on the AWS. Okay, so let me just show you how do you do this. So for that, if you sign into the AWS Management Console, here in the services, you can click on storage and here you should click on S3. So S3 will be using for storing our data. So once you come on the S3 homepage, Amazon S3 homepage, here you can see the option of creating a bucket. Okay, so now we will click on create bucket here, enter the name of the bucket, anything that you want. So say for example, my bucket and Edureka. Specify a region here. So I'll be selecting this one, Asia Pacific, Mumbai. And here you should click on create. So as you can see here, this bucket has been created, my bucket Edureka. So now click on this bucket and we have to create 4 folders here. Okay. So the first folder will be input for storing the input files. And after creating a cluster and running the queries, so whatever the output will be generated, it will be stored in the second folder, which is the output folder. The third folder is the log folder, which will consist the logs. And the purpose of log files is to debug the Apache Hive queries. Like if you're running a query and if there is an error in executing that query. So for that purposes, for resolving such errors, we can make use of the log files. And the fourth folder is the script, where we will store all our queries in the form of .q files. Okay, so let's just quickly create folders, 4 folders. First one is input, name the folder as input and click on save. Next, we will create the output folder, click on save. The third folder is the logs folder and the fourth folder is the scripts. Okay, so as you can see, these 4 folders have been created here. Now let us click on input and here we will upload our input files. So these are the 2 CSV files. Click on upload. So as you can see here, both these CSV files have been added here in the input folder. And now let us add scripts here. So for that, click on upload here, click on add files, and then you must browse all those. Okay, so there's also this file called log-aggregation.json file. I'll tell you more about this file in the later part of the video. And we must also upload this JSON file in the script folder. Okay, so once you select all these 4 files, the first 3 files are the queries that we're going to run, and the 4th file is the JSON file. Okay, so click on open here, click on upload. Okay, so as you can see here, we have added these 4 files here in the scripts folder of the Amazon S3 bucket. Okay, so now we are done with the S3 part of this demo. Now let us talk about the EMR. Okay, so here we are going to create a cluster. So for that, there's an option of create cluster here. You can name your cluster whatever you want. So say for example, my cluster Edureka. So here you can see the option of logging. It is by default checked. And if you remember in the previous step, we created one logs folder in the Amazon S3 bucket. So we just need to specify that here. So for that, click on this folder icon here and select your bucket and click on the logs folder and click on select. Okay, so this has been done here. So by default, the release is EMR 5.28.0, and this is the application which is selected by default. So here it has core Hadoop, Hive, 𝐓𝐫𝐞𝐳, and pig along with 𝐷𝐨. So in the security and access section here, there's an option of EC2 key pair. So here you need to create a Amazon EC2 key pair. Okay, so if you click here on this link, learn how to create an EC2 key pair, it will show you the guidelines. Okay, so these are the steps that you need to follow to generate an Amazon EC2 key pair. So go to the Amazon EC2 console, click here, it will navigate to the EC2 console. So if you see here in the left hand side, here there is an option of key pairs. Okay, network and security key pairs. If you click on this, okay, so these are the few of the keys that I've already generated for my previous purposes. And now let's just create a new key pair. So for that, click on create key pair, and you can name the key whatever you want. My key, say for example Edureka. So you just name it and the file format. So there are 2 options here. One is the PEM or the PPK. So here I'm selecting the PPK, putty private key. Okay, so we will talk about this PPK or the putty private key in the later part of this session, and click on create key pair. Okay, so here as you can see, successfully created key pair, and this key pair has also been downloaded on your system. As you can see here, my key edureka.ppk. So this is how you create a EC2 key pair, and as soon as you create this key pair, you'll have this option of choosing this my key Edureka. So this was the key pair that we created just few seconds ago. So I'll just select this, okay, and click on advanced option here. So here mostly we will be going with the default options here. Yeah, so in this section, edit software settings, you have to click on the JSON, load JSON from S3. So if you remember, we had one JSON file which we uploaded in the script folder of the S3 bucket. So we just have to navigate to that and select that file. So you have to select your bucket here and go to the scripts folder and select this log aggregation.json file. So you just have to select this here and click on next here. So here in the step 2, which is the hardware configuration, we are going with the default options. Click on next. Okay, so I'll just quickly rename this my cluster Edureka and select the log folder. Once we are done with this, click on next. The 4th step is the security. Here we have to select the key pair that we created and click on create cluster. Okay, so creating cluster might take a few minutes. As you can see here, it is showing the message starting. So from starting it will proceed to running, and from running it will be waiting. Okay, so once it enters the waiting state, then we will add steps to this cluster to process the Hive queries. Okay, so the next step here is allowing the SSH access. For that, what you need to do here is, so this is the cluster homepage, and here in security and access, you just need to click on elastic MapReduce master. Okay, so this is the link for that. Just have to click here. Okay, once you click on that, you have to select the master here, elastic MapReduce master. And here, as you can see, you have to click on the inbound tab. After that, click on edit. So here, what you need to do is click on add rule here and select SSH from this option type. And by default, it will be TCP and the port range will be 22. And here in the source, you have to click on my IP. Okay, so your system's IP will appear here and you have to click on save here. So once this is done, you can do it same for the slave as well. Okay, so normally what happens in real time, cluster is nothing but, there's one master and multiple slaves. So the cluster that we have created here, it has one master and two slaves. So normally what happens is slave is a different machine and master is a different machine. But in this demo here, the master and the slave is the same machine. Okay, so optionally you can configure the slave as well, just as you configured the master. Okay, so it is optional. And once you're done with that, you have to click here on SSH. Master Public DNS is an option of SSH here. Once you click here, okay. So here, depending upon the operating system that you're using, there are a few steps that you need to follow. And using this step, we can connect to the master node using SSH. Okay. So if you have Mac or Linux, you can follow these steps. And if you are using Windows OS, you can follow these steps. For that, you'll be needing one application called Putty. And the link for that has also been provided here. Just go on this link and download this application. So I've already downloaded this on my system. So what I'll do is I'll just quickly open that application, PUTTY. So here it is asking for the host name or the IP address. For that, you have to select this, Control C, Control V. So once you're done with this, click on the connection here. After clicking on connection, you can check this box, enable TCP, keep alive, and then click on SSH. Here you have to click on the authentication tab here. And if you remember, we had generated one PPK file or the EC2 key pair. You just have to browse here that key from the downloads. My key Edureka was the name, and you have to select here. Okay. And here you have to click on open. Okay, so once you do that, you'll get this message here, security alert. Just click on yes. Okay, so now we are connected to the master node using the SSH. Okay, so now our cluster is in the waiting state and we are good to proceed further. So what we will do here is, here click on steps. Okay, so basically we will be running our Hive queries here. So for that, click on add step in the step section. Step type, select Hive program here and select the script for this. So for that, you have to browse to the S3 bucket script and click on. Okay guys, so I just missed uploading one more file here. So let's just quickly do that. Okay, the first query, the create table query. Let's just upload this. We are uploading this file in the scripts folder of our bucket, S3 bucket. So as you can see here, now we have 4 queries here and one JSON file. So let's just quickly go back to our cluster here. And we just need to add one step here. Like for executing 4 queries, we'll be needing 4 steps. So if you click on this step section, click on add step, select Hive program, select the script location, create table. Okay. So the input for this is the CSV files, which are stored on the input folder of our bucket. Once you do that, select the input folder, select the output folder as well. Okay. So this is the default action on failure, continue. Okay. Click on add here. So running this step might take a few seconds. As you can see here, the status is pending. And once this status turns from pending to completed, we will add remaining steps in a similar way. If you have any queries related to this session, you can post them in the chat box below, and my team is here to help you with all your queries. Okay, so as you can see here, the status has changed from pending to completed. So similarly, for remaining queries, you have to add steps in the similar way. Select Hive program, select the script location, the input and the output. Click on add, and let's just quickly add two more steps here. And we will also have a look at the output after these queries are successfully executed. I'll show you how do you view the output of these queries. Okay, so now let us just quickly select the input and the output. Click on add, and we'll just add one last step for the fourth query. Okay, so as you can see here, two queries have been successfully completed, and the status of the remaining two queries, one is pending and one is running. Okay, so if you refresh this, okay, so as you can see here, we had four queries and all the four queries have been successfully executed. Okay, so this is how you execute your Hive queries on the top of your data using the EMR cluster. So guys, with this, we have come to the end of this session on big data in AWS. And I hope you have enjoyed this session and you have understood whatever we have done here. If you have any queries related to this session, you can post them in the chat box below, and my team is here to help you with all your queries. So that's it from my side in this session. Thank you so much.